Imagine two particles separated by thousands of kilometers across the galaxy. You measure one particle and instantaneously, faster than light could ever travel between them, the other particle responds as if connected by an invisible thread. This isn't science fiction, it's quantum entanglement, a verified phenomenon that led Einstein to famously call it spooky action at a distance. Even more perplexing, these measurements appear to violate the fundamental speed limit of the universe. Nothing should travel faster than light, yet this information somehow does. Welcome to the frontier of scientific mystery, where the rules, as we understand them, begin to unravel. The enigma of the unknown science prides itself on explaining the universe through observation, experimentation, and rigorous methodology. Yet, scattered throughout the landscape of human knowledge are phenomena that stubbornly resist our best attempts at explanation. These aren't mere gaps in understanding. They're gaping chasms that challenge the very foundations of what we think we know. Consider for a moment, 95% of our universe consists of dark matter and dark energy, substances we can detect only indirectly through their gravitational effects. Without this invisible scaffolding, galaxies would tear themselves apart. Yet we've never directly observed a single particle of dark matter despite decades of searching. It surrounds us, shapes cosmic evolution, and remains as elusive as a shadow in darkness. Or ponder this. In 1977, a radio telescope at Ohio State University detected a signal so powerful and unusual that the astronomer on duty wrote, "Wow," next to the data printout. The 72-second burst came from the direction of Sagittarius, appeared to have intelligent characteristics, and has never been detected again. Was it an alien transmission? A natural phenomenon? The answer remains locked away, just beyond our grasp. These mysteries aren't failures of science. They're its frontiers. Each unexplained phenomenon represents a doorway to potential revolutionary understanding, if only we could find the key. As we venture deeper into these enigmas, the line between established science and the seemingly supernatural begins to blur, not because science is inadequate, but because reality itself may be stranger than our minds evolved to comprehend. The challenge of the incomprehensible. The scientific method, that reliable engine of discovery, operates on specific principles: observation, hypothesis, experimentation, and verification. But what happens when phenomena occur so rarely or unpredictably that controlled experiments become nearly impossible? What about effects that change when observed, or concepts that may exist beyond our perceptual framework altogether? These challenges create a paradox for researchers. The scientist must remain skeptical and demand evidence, yet also remain open to possibilities that might seem, at first glance, to contradict established understanding. This tension between skepticism and openness defines the cutting edge of scientific inquiry. Take quantum mechanics, for instance. Richard Feynman, Nobel laureate in physics, famously stated, "If you think you understand quantum mechanics, you don't understand quantum mechanics." This wasn't false modesty. It was recognition that quantum behavior defies our intuitive understanding of how the world works. Particles exist in multiple states simultaneously until measured. Information appears to travel instantaneously across vast distances. Objects can tunnel through impenetrable barriers. These aren't just puzzles awaiting solution. They may represent fundamental limits to what human minds, evolved to navigate the macroscopic world, can truly comprehend. As physicist Niels Bohr noted, "Anyone who is not shocked by quantum theory has not understood it. Phenomena beyond explanation. Ball lightning, the floating enigma." You're sitting at home during a thunderstorm when suddenly a glowing orb the size of a grapefruit floats through your closed window, hovers in the living room for several seconds, then disappears with a pop. You haven't been hallucinating. You've witnessed ball lightning, one of atmospheric science's most persistent mysteries. Ball lightning appears as a luminous sphere that can range from pea-sized to several meters in diameter, floating a few feet above the ground during thunderstorms. Unlike normal lightning, which lasts just microseconds, ball lightning can persist for seconds or even minutes. It can pass through closed windows and solid objects, occasionally exploding and leaving behind a smell of sulfur. Despite centuries of documented observations, scientists struggled to even prove ball lightning existed until 2012, when researchers in China fortuitously captured it on video while studying ordinary lightning. Their spectrometer analysis revealed something remarkable. The floating orb contained silicon, iron, and calcium, elements abundant in soil 3. This suggested that when lightning strikes the ground, it might vaporize silicon in the soil, creating a plasma that glows while silicon recombines with oxygen in the air. Yet many questions remain. Why do some witnesses report ball lightning passing through closed windows without damage? How does it maintain its shape and energy for extended periods? The answers remain elusive, making each occurrence both a scientific curiosity and a potential key to understanding new states of matter. The placebo effect, mind over matter. Imagine two groups of patients with chronic pain. One receives a powerful new analgesic. The other gets sugar pills that look identical. Remarkably, about 30% of those taking sugar pills report significant pain reduction, a result indistinguishable from many actual medications. This is the placebo effect, a phenomenon where inactive treatments produce real physiological improvements. What makes the placebo effect so challenging to understand is that it produces measurable biological changes. Brain scans show that placebos activate the prefrontal cortex, which can modulate pain perception through top-down processing. Endorphins, the body's natural painkillers, are released. Inflammation markers decrease. These aren't imaginary changes. They're concrete physiological responses to essentially nothing. Even more fascinating, recent research by Harvard's Catherine Hall has identified genetic factors that influence susceptibility to the placebo effect. A mutation in the gene for catechol-O methyltransferase, COMT, an enzyme that removes dopamine from neural synapses, can enhance placebo response. People with less efficient COMT may respond more strongly to placebos due to increased dopamine signaling. The implications are profound. If the mind can trigger healing responses without actual medicine, could we harness this power more effectively? Could the boundary between real and psychosomatic conditions be more blurred than we've acknowledged? The placebo effect challenges our understanding of the mind-body connection and suggests that consciousness itself might be a therapeutic agent. The Tunguska event, the day the sky exploded. At 7:17 a.m. on June 30th, 1908, something extraordinary happened in the remote Siberian taiga. A blinding flash lit up the sky, followed by an explosion estimated at 12 megatons, roughly 800 times more powerful than the Hiroshima bomb. The blast flattened 80 million trees over 2,000 square kilometers. Witnesses 40 miles away were knocked off their feet. The air pressure waves circled the globe twice. Yet when scientists finally reached the site years later, they found something baffling. No impact crater. Despite the catastrophic damage, whatever caused the explosion had apparently disintegrated before hitting the ground. The leading explanation is that a meteoroid or comet fragment approximately 60 to 190 meters wide exploded about 5 to 10 kilometers above the Earth's surface in an airburst. But significant questions remain. Why has so little extraterrestrial material been found at the site? If it was a comet, which would explain the limited debris due to its icy composition, Why didn't witnesses report the brilliant tale that should have been visible for days before impact? Alternative theories range from a natural hydrogen explosion to antimatter to micro-black holes. Some even suggest it was an alien spacecraft malfunction, an idea that, while lacking evidence, illustrates how extraordinary events push the boundaries of our explanatory frameworks. The Tunguska event reminds us that even in the modern era, nature can produce phenomena that defy easy categorization and explanation. The double-slit experiment, reality's deepest mystery. If there's one scientific enigma that keeps physicists awake at night, it's the infamous double-slit experiment. Simple in setup yet profound in implications, it may represent the most fundamental mystery in all of science. Here's the experiment. You fire individual particles, electrons, photons, even entire molecules, at a barrier with two parallel slits cut into it. Behind the barrier is a detector screen. Logic suggests each particle must go through either the left slit or the right slit, creating two distinct bands on the screen behind. But that's not what happens. Instead, the particles create an interference pattern, alternating bands of particles and empty spaces as if each particle traveled through both slits simultaneously and interfered with itself like a wave. This wave-like behavior from particle-like objects is strange enough, but it gets even more bizarre. When scientists install detectors to watch which slit each particle travels through, something extraordinary happens. The interference pattern disappears. The mere act of observation changes the outcome. Particles seemingly know they're being watched and behave differently. It's as if reality itself is conditioned on whether anyone is looking. All of the mystery of quantum mechanics is contained within this experiment, according to Richard Feynman. It demonstrates the principle of wave-particle duality, that matter and energy can behave as both particles and waves, and suggests that particles exist in multiple states simultaneously until measured, a concept called quantum superposition. But the deepest mystery lies in what this tells us about reality itself. Is the world fundamentally indeterminate until observed? Does consciousness somehow collapse probability into actuality? Or are there multiple universes where each possible outcome occurs, with our consciousness only experiencing one branch of reality?